Hello students, good evening to all of you all. Assalamu alaikum. Welcome to the online session. Can you all hear me clearly and see the screen clearly? Am I audible to you all?
Yeah, sir.
Yes, sir.
Okay, good. So let's go into the discussion. Yes. Okay, so actually today's session is like the continuation of last week's one. The students who are not there for the last week's session, don't worry, I will be uploading the recording in YouTube. Along with this, I'll be uploading the recording. Yeah, there are some comments, videos are on. Yes, some students recommended that on and off have the video on so that we can see you, Kiela. Okay, Menna. Okay, so let's go into the extraction of iron. Yeah, shall we try the question and come to the theory part? I hope you all tried this 2016 question. It is one of the hardest question. Let's go to a little bit easier one. That is the last year's question. 2024, last year O-level paper. Is my sound clear to you all? Because background there is some vehicle noises. Am I audible to you all? Clear? Is it clear?
Yes, sir.
Okay, good.
Yes.
Yes, we'll start this question, and then when explaining this, I will explain all the equations related to this blast furnace. Okay. Yeah, on a large scale, iron is produced by heating a finely powdered mixture of Fe2O3, that is hematite, that is taken from the iron ore. So hematite plus impurities are there. There is another story about the impurity that also we will discuss about it. Then limestone and coke. Those are the three raw materials. Iron ore, which contains hematite, then limestone, and coke, which is pure carbon. At high temperature, the temperature is about 800 to 180. Now normally we say 2000 degrees Celsius to 200 degrees Celsius. That's easy for us to keep in mind. What is the advantage of crushing the mixture into fine powder? This is not related to the industry, it's related to rate of reaction. You all know when the substances are crushed into fine powder, okay, the surface area increases. When the surface area increases, a rate of reaction increases. So this reaction happens fast. So that is the advantage. By powdering, we increase the rate of we increase the surface area. Therefore, the rate of reaction increases and the reaction happens fast. You can explain it. So I have given the key point. The main reaction taking place in the blast furnace process during this process are given below. Letter X and Y and Z in them represent three chemical compounds. So we'll see what is happening. Initially, they are telling us calcium carbonate is heated. When calcium carbonate, limestone, is heated, it breaks down to calcium oxide plus carbon dioxide. So can we write the reaction will occur fast? Yes, but mention the reason: surface area increasing. For now, if you put the reaction will increase or the rate of reaction will increase, okay, superb, that's correct. But next time when you are writing, now only you all are getting little by little the O-level practice. So write it clearly that the surface area increases, therefore the rate of reaction increases. Okay, now this set of reactions, we'll study it one by one. Yeah, let's go to the screen. So let's say once you put all these three ingredients, initially what happens is the coke which you put reacts with oxygen and forms carbon dioxide. Here this equation is naturally balanced. One carbon this way, the one carbon other way. Two oxygen shape. It's naturally balanced. So the ratio is 1:1:1, no problem. Then the produced carbon dioxide, I'm telling you all the full reaction what is happening in the blast furnace from top to bottom. The carbon dioxide which is produced from the first reaction reacts further with coke and forms carbon monoxide. Normally carbon monoxide is poisonous gas, useless gas, but in this situation, carbon dioxide is really helpful. So it forms carbon monoxide. So to balance the equation, we have two carbons on the left side, two oxygens on the left side. Right side we have 1 and 1. We just put 2 here. It automatically balances. So the ratio is 1:1:2. Hope you all are clear about it. Third one. The produced coke will react with hematite, Fe2O3 plus carbon monoxide will produce the most important compound here. We are heating all these finally to get iron, Fe, pure iron. We will get pure iron because the temperature is very high. It will be in the liquid format, and in the setup, it will go down and get settled at the bottom. So if you draw a blast furnace like this, hot air blast is sent from the bottom, and here the needed ingredients are collected. Fe is collected. So this is so hot you can't use any metals or you can't use any iron structure because that will melt. So we use fire bricks. This is like a very tall building, like 20 floors high, 60 meters height. So here it's about 1600 to 1800 for easy. This one we put 2000, and when going to the top it will be about 200 degrees Celsius. In between these only the reactions are happening. It produces pure Fe and releases carbon dioxide. Balancing this equation, you have to little bit think. Here already 3 oxygen is there. Here also oxygen is there. But when you try to change the oxygen value, this side automatically carbon changes. So we have to put one number here and here so that the carbon is also balanced, oxygen is also balanced. So we can try with one, it won't happen because now it's in one stage, here it's 1 and 1. It's not balanced. You can put 2 and 2. When you put 2 and 2, carbon is 2, but oxygen 2 into 1, 2, and here 3, it's becoming 5. So the most suitable balancing one will be 3 and 3 because we have to balance the carbon. Where is the blast furnace normally found? In Sri Lanka, currently I think we don't have a blast furnace, but our ancient kings used to have to make this iron swords and all. They used to sell that to the Arabian kings and all the other country kings. Now we get the imported ones. So in Sri Lanka, I'll just will check and see where if it is available in any place. But normally in the other countries, they have a industrial place, big area, okay, to make all these things. Yes, balancing part. Now we tried it with 2. It didn't work out. So let's try it with 3 and 3. Now check and see 3 carbon. This side also 3 carbon. 3 oxygen, 6 oxygen on the left side. 3 into 2, 6 on the right side, balanced. Fe2 here, and we put 2 here. Hambantota, Google says there is one in Hambantota. Okay. So the ratio is 1:3:2:3. That is one of the most important equation because that 2016 O-level paper is totally based on that question, purely that question. That equation. If you don't know that equation, you can't do that question. That kind of a thing. Then now our main things, hurry. Coke has been used. Hematite has been used. Then why did we put limestone? How to find the ratios? Yeah. So Buddha, when we are balancing, we are putting some numbers, right? Those are the ratios. If you don't put a number, it's 1. So here it's 1, 3, 2, 3. 1, 3, 2, 3. Why do you put these mole ratios? If they ask the mole ratio, you can write it. If they give a calculation question related to this, then we need the mole ratio to do the calculation part. Okay. Fourth one, now let's talk about the limestone. Calcium carbonate. When calcium carbonate is heated, it will break down to calcium oxide plus carbon dioxide. And here it's naturally balanced. Calcium left side 1, right side 1, carbon this side 1, oxygen 3, and this side 1 plus 2, 3. Naturally balanced form. This calcium oxide, we call it quicklime. Calcium carbonate's short name is limestone. Remember, like this quicklime is like a police. He will capture the impurities. There are 2 impurities when putting the hematite, the iron rocks, the iron ore. There are 2 impurities. We call it silica. One is silica, SiO2, silicon dioxide, and alumina, Al2O3. It's amphoteric oxide. First term itself, we have studied much about it. Do we have to memorize this? Yes, Nebuda. There is a pattern. Carbon to carbon dioxide. Carbon dioxide to carbon monoxide. Carbon monoxide reacting with hematite to form pure iron. And then this limestone. Limestone equation, you have studied it in many places, even in chemical decomposition,
Sure.
production of carbon dioxide. Those places also we have discussed.
So,
Yes.
silica and alumina make slag, right?
Yeah. Not silica and alumina. They will join with. Now I'll explain that part, Balanna. These are the impurities. These impurities will be trapped by this police. How the police? Calcium oxide. Calcium oxide plus silica will form calcium silicate. Actually, don't think this is very hard and all. Just add the formulas, the elements, and just put it. It will form calcium silicate. CaSi. Totally, there are 3 O's, no? O3. This is known as calcium silicate. Silica to calcium silicate. Now, alumina story. Calcium oxide plus alumina, Al2O3, will form calcium aluminate, CaAl2. On the left side, we have O4s. O4. So the name will be calcium aluminate. This calcium aluminate and calcium silicate together forms a special substance known as slag. SLH. Actually, the slag is also heavy, but not heavier than iron. So the liquid slag will be floating here. Actually, in the real industry, slag is preventing other impurities from falling back to the pure Fe. So the slag prevents some stones or other impurities falling and reacting with Fe. If something falls, the slag will hold it. It won't allow those impurities to go to pure Fe. Finally, pure Fe can be extracted from the bottom. So this method is known as thermal reduction method. So from the activity series, you all know Can you all remember the first few elements? I have given a short form. Kalekata ne cash mage almariye. Kalekata ne cash mage almariye. Zainab fear snakes publicly. Zainab fear snakes publicly. Then hydrogen. CEO Hagrid ke partiya aulvela. CEO Hagrid ke partiya aulvela. This is my short form. I think this is one of the easiest method to memorize the activity series. Kalekata ne cash mage almariye. Zainab fears snakes publicly. Then hydrogen. CEO Hagrid ke partiya aulvela. Okay, I have explained everything related to this in our theory classes. I hope you all can remember. The extraction method of the first few elements are electrolysis. Electrolysis method. The extraction method of the next few elements. Hydrogen is a non-metal. Why is it there? There is a big reason for that. We have discussed about it. Okay. Other than the hydrogen, all the other metals, including copper, can be extracted by thermal reduction. Thermal reduction method. And Hagrid ke partiya aulvela, that is mercury, silver, platinum, gold, can be extracted by physical method. So you will study this electrolysis method. They are highlighting sodium, and in grade 11 they will give the full industry related to sodium, that is known as down cell. The grade 11 students, recently we have completed that under electrochemistry lesson, the full industry related to sodium extraction by electrolysis, by giving electricity. When we do a reaction, we call it electrolysis. By that method, we are extracting the sodium. That equipment is known as down cell. Thermal reduction, not in grade 11, in grade 10 itself, we are studying much about the iron industry. Okay, that is known as the blast furnace. Physical method, we will be studying about gold. Already in grade 10 also, we got a slight idea. In grade 11, we will study evaporation or vaporization technique to purify gold. That is known as amalgam method. Okay, so all this we will be discussing in these two. Down cell and amalgam method we will be discussing in grade 11. Blast furnace, just now we discussed, it's the grade 10 part. If you all want, you all can take a screenshot. It will be useful. Yeah, sorry, I have put the line for gold. Sorry, silver. AU is only gold, not AG. AG is silver. Silver extraction we don't have in our syllabus. Gold extraction is there. So you can take a screenshot. CU belongs to thermal reduction, yes. According to our O-level syllabus, CU belongs to thermal reduction. Physical method also, they say some places you can get it, but normally in our syllabus, we go with thermal reduction. Yeah, I'll show the blast furnace part, that equations are there. Take a screenshot of this, then I will show that, because this screen will go, that screen will, it's a permanent screen, this is a temporary one. Hope you all are clear about it. Yeah, because the Isha Azan is very quick. I will give the Maghrib break. Give me a minute. This is the blast furnace, the theory related to blast furnace. Yeah, you all can copy it down. The ones who didn't pray Maghrib, you all can pray Maghrib. I'll give a 10 minutes break. After that, we will continue. All the equations related to the blast furnace are in one screen. It will be really helpful. You all, and the balance equations also there. Yes, please take a screenshot. I will show you the question. Then the ones who prayed, because the ones who completed the prayers, you all can start the question. The others can soon pray and come. Did you all take a screenshot of this? Done. Then this is the 2024 question. The ones who didn't do it, quickly you can start. Yeah, the fourth equation is naturally balanced. No, this one naturally balanced. 1:1:1:1. All the others are naturally balanced. Even the silica thing, 1:1:1. Silica, calcium silicate, calcium aluminate, that the equations are balanced. Yes, now you all can find what is X, what is Y, then again Y, what is Z, what is Y. Okay, now superb, you can identify everything clearly. X, Y, Z. Of the above reaction, which can be considered as acid-base reaction, we'll come to that. Okay, yes. Please do the question. Okay, students, let's continue. So here X, Y, Z, we have already identified it according to our equation. X is calcium oxide. Y is carbon dioxide gas. So here it's perfectly fitting, no? Carbon plus oxygen, carbon dioxide. Here carbon, coke plus carbon dioxide. Z is only carbon monoxide. And they have already balanced. Can you see they have put 2, 3 and all those things. So we don't need to worry about the balancing part. They have balanced it perfectly. Then of the above reaction, which can be considered as an acid-base reaction, okay, because here it's not like a pure acidic reaction or basic, chemical acids and chemical bases are not there. Actually, acidic oxide plus a basic oxide is undergoing a reaction. So grade 10 you all have studied, no? Towards the left of the periodic table, there are basic oxides. Towards the right, we have acidic oxide. For that, we have drawn a chart also related to that. Give me 1 minute. Huh? Okay, now Harire, yes. So when you look at the oxides, there is a chart. I think in our previous paper classes I have given you know from sodium to chlorine. In our syllabus they have given, I have given a short method to get all those things. So from that we know the acidic oxide is SiO2, slightly acidic. The only basic oxide here is calcium oxide, because this is towards the left of the periodic table basic oxide. This is acidic oxide. So that is the reaction. So you can write silicon dioxide and calcium oxide reaction, or you can write the equation number according to this. No, they have not given number. No, they have given the numbers here. Fifth one. You can write fifth reaction, or you can write the reaction. No problem. You will get the mark. So 1 mark for the first one, the powdering thing. Why is the powder one best? Second one, we get 3 marks for identifying X, Y, Z, 3 marks. And here this one, 1 mark. And last one, calcium silicate formed in the reaction 5 floats as slag on the extracted molten iron. What is the advantage? For this you will get 1 mark. I will explain the advantage. So in while periodic table, there are acidic and basic oxides. You're asking that as a question there. Yeah, we have studied that. No, in our theory class also we discussed that. In paper also we discussed. Okay. If you are writing the reaction, you can write it as for this third one, SiO2 plus CaO equals CaSiO3. Like that you can write, or you can just put the fifth reaction. Because they have numbered the reaction, they have given it. This is our answer for the third one. Okay, the ones who don't know about the oxides, I'll give you all the oxides. According to our syllabus, they have given the third period only. Sodium, from sodium to chlorine, it forms the oxide. So I told the students, now some equations we can derive it. Some equations, some formulas we can't, because it is A-level related. Then how do you remember that? Very simple way. First write the elements. For the periodic table also we have given a short form, no? Hi, he, London, B, C, not only Friday, Nia, Nana, MGR, Allah, the Sivaji, P, S, Kla, R, Kaka, Nia, then Nana, MGR, Allah, the Sivaji, P, S, Kla, R. Argon doesn't form oxides, so we can cut it off. Now we have to write the oxides of all these. So easiest method is put 2, 2, 2, 2, 2, 2, 2. And fill the oxides O1, O2, O3, O4, O5, O6. Now these are the basic formulas. In this chemically, if there are same numbers, we can cut it off. Other one is if there are numbers which can be divided by 2, we have to divide it by 2. So finally we'll give the last one here. In chemistry, we don't show 1. So you can finally write as sodium oxide. Magnesium oxide, here 2 and 2 is there. So you can cut both and you can just directly put magnesium oxide. You all have studied all these rules in the formula lesson, no? Al2O3, nothing to cut, directly we can write. Si2O4, we can cut the 2 and 4 and make it Si1O2, we can directly write SiO2. Then P2O5, nothing to cut, nothing to do, we put P2O5. S2O6, you can divide it by 2, S will be 1, O will be 3. Chlorine oxide, sorry, I forgot to put the oxygen here, O7, no? You can't do any changes here, Cl2O7. This one they have given in our syllabus, grade 10 basic chemistry part. Many schools, they are skipping this part. Okay, if I ask you now, you can just tell me. Can you all raise the hand? How many of the schools, they didn't do this oxide part? You don't need to mention your school, just raise the hand. Can you all see more than 11 students? 12 students have raised the hand. 14. Okay, this is there in your textbook. Check under patterns present in the periodic table. In that, the first pattern is electronegativity. That most of the schools they explain. The other one is first ionization energy. That also they explain. Then next one, metal, non-metal, and metalloid. And the last one only they skip it. That is the acidic basic nature of oxides. This is in the part 1 book. This is in the part 1 book. The students who don't have the part 2 book, all the PDFs are available, Putha. You all can purchase, you all can download it from the etaksalava.lk. Or else the students who are coming to my classes, don't worry. For all the lessons, we have tunes. Okay, all the lessons we have tunes. Now, for example, our last tune, mostly this month, we will be sending to our online students. This is our tune. Okay, this is related to electricity and inheritance. So this has our, now next week we are starting electricity lesson in our online classes. Physical classes we almost started the, this one, electricity lesson. And the last lesson is inheritance. So all the printed notes are there, workouts, workings are there. So the ones who are coming to my class, you don't need to worry about textbook. But the ones who are not coming, if you all don't have the textbook, because nowadays you can't purchase the textbook if there is demand. They are not printing the whole textbook. So you all can download the PDF and get it printed. Harine, give me 1 minute. Just now only one student is asking the class day. Okay, so now I'll tell you how to identify acidic basic. Here they have said this fellow is a special fellow. He shows both acidic and basic, both the properties. So he gets a special name, amphoteric oxide. Amphoteric oxide. He has both acidic basic property. This is a special O-level question. Commonly in many O-levels past papers you can see what is this Al2O3, what is the amphoteric oxide. Okay. Then next one, towards the left side we have basic oxides. Towards the right side we have acidic oxide. Out of that, more acidic is chlorine. Very strong acidic nature is there. Because later if you put this in water, it can form HCl, hydrochloric acid. Then this one is a strong acid. When you put it into water, it will form H2SO4. The P2O5, oxide of phosphorus, it forms a weak acid, weak acidic oxide. SiO2, very weak acidic oxide, but still it's acid. This fellow is amphoteric. In between both, magnesium oxide is weak basic oxide. This is strong basic oxide. The whole thing is there. If you all want, you all can take a screenshot. So will it explode if you mix all the strong acids? No, no. If you mix acid, it won't react. But if you mix acid and a metal, okay, like sulfuric acid and potassium, chemistry lab is on fire. Harida, you all can take a screenshot. I am not giving you all time to write because this is not theory class, and the other thing is we have to discuss more questions. But in our paper classes, Puta, you get a lot of theory understanding. Okay, there are some paper classes I have seen in YouTube videos. They show the question. They're like, this is the answer. Note it down, correct it. Next question. So they do more number of questions. They advertise like they do 1,000 questions. You can do 1,000 questions. But if you don't even understand one question, no use of doing 1,000 questions. No. That's why now in grade 10, our main target is by questions, we are understanding most of the theory. Once you come to grade 11, you will be doing every week 40 MCQs, sometimes 50 MCQs. Can you tell me how to identify? You can't identify. You can have an idea that towards the left of the periodic table, the metals especially, mostly are basic. The non-metal side, right side, more towards acidic nature. The strong acid, strong base of these ones, third period, is mentioned in our syllabus. It is mentioned. This one, each and everything you all should know. Others, now calcium oxide, here calcium oxide, if we know it is basic oxide, it is enough. But whether it is strongly basic or weakly basic, they won't ask because that is directly not mentioned in our syllabus. Okay, but these ones, sodium oxide, magnesium oxide, aluminium oxide, silicon oxide, phosphorus oxide, sulfur oxide, and chlorine oxide, which is in front of your eye now, that is like compulsory, you should know. If they ask, you should be able to answer. Because already given in our syllabus. Yeah, better to take a screenshot and write it down later. Okay. Hari, shall we move to the question? So that part is also done. No. Next one is, what is the use of this slag? Now, Buddha Balanna, in blue, here black color I am coloring something, right? That is the mixture of these two. These two's mixture is known as slag. Slag will be floating over the POFE which is formed. This is the molten iron, pure iron. Some impurities, because you are putting a lot of things here, those impurities might fall and go to the Fe. But what does this slag do? It acts as a barrier from impurities falling into molten iron. That is the use of slag. It acts as a barrier. It acts as a barrier to prevent other impurities falling into molten iron. Yeah, one girl has written, traps impurities in a molten layer, guarding the pure iron. Correct. If your answer is giving that idea, then it's correct. I hope you all are clear. Yeah, let's go to the next calculation part. It's the important part. Can we get the recording of this class? Yes. This SiO2 thing, that will be most probably March classes. Uda, the azan is going on. I'll mute it for 2 minutes. Okay, then let's go to the discussion. Are you all clear about the definition of slag? Again, the function of slag, and this is the composition of slag. Calcium silicate and calcium aluminate. They come from silica SiO2 and alumina Al2O3 joining with calcium oxide. So Bob, now that full explanation is there. This is the maximum. You're 100% clear. Okay, so if you get a O-level question related to it, without missing any point, write it down. Okay, now this is a little bit of a tough question. According to equation 4, how many tons? My God, how many tons? Tons කියන්නේ මොනවාද? Okay, many O-level students last year, they knew the whole thing. Science part, they knew everything. Again, most of my students, this hematite industry, they are more clear. But they were unable to get the final answer because they did not know the meaning of tons. Okay. Tons කියන්නේ, they knew what is ton. 1 ton, 2 ton. They did not know how many kilogram is that. 1000 kilogram is 1 ton. Okay, 1000 kilogram. So, how many tons of hematite are needed to extract 70 tons of iron? Okay, so this question, first we have to write the equation. Hematite formula. Fe2O3 plus carbon monoxide forming POFe plus releasing carbon dioxide. Now you all know how to balance this, no? 3, it's a different color. 3 here, 3 here, and 2 here. The mole ratio is 1:3:2:3. Now you might think, 70 tons of iron. If I want to get 70 iron, I can use half of 70 is 35. 35 tons of Fe2O3. Because the mole ratio is 1:2. No. Because here 70 tons can a mass. We can't get the mass ratio like this. So we have to find the number of moles. Okay. So this is the mole ratio, number of moles. The meaning of this is, 1 mole of Fe2O3 will react with 3 moles of carbon monoxide and form 2 moles of Fe and 3 moles of carbon dioxide. This is the meaning of this mole ratio. So if I need 2 moles, to form 2 moles of Fe, I need 1 mole of Fe2O3. So if I want to get 70 tons, 70,000 kilograms, we convert to grams, this is the amount. Divide by, you all know the equation, N equals simple M over capital M, grade 10 equation, to convert mass into moles. Number of moles of Fe needed is calculated by the given mass of Fe divided by the molar mass of Fe. Here given relative atomic mass of Fe is 56. Okay. So this is the number of moles of Fe. Then this one's half amount only needed for is only needed for Fe2O3, number of moles. Now, for example, here I am not doing the calculation part. We will do the calculation part last. I am keeping it like a fraction. If my answer was, like just an example, 1000 moles, to get 1000 moles of Fe, how many moles of Fe2O3 do I need according to the mole ratio? Yeah, you all can unmute. Easy question, no? Yeah, I will need 500, no? I will need 500.
Why 70 million?
Yeah, 70 million because they have said 70 tons of iron. I need to produce 70 tons. So when we convert it into kilograms, 70,000 kilograms. When you convert it into grams, 70 million grams divided by 56 grams per mole. That is the unit of molar mass. Now I need half of this. So that means I need half into 70 million divided by 56. This will give the number of moles of Fe. But are they asking the number of moles? They are asking the mass. Then how to convert moles to mass? Again, use the N equals simple M over capital M equation for this side. Already we have used it to find the number of moles of Fe. Now we are going to use to find the mass of Fe2O3. So if I need to find the mass of Fe2O3, I have to multiply now I have to send the molar mass to the other side. Now this is the equation, right? You all know the maths, right? Mass equals number of moles into molar mass. What is the molar mass of Fe2O3? Separately you have to try get it. Fe2O3. Fe is 56 into 2. Because there are one Fe is 56, there are two Fe. Oxygen 16 into 3. Then add both. 56, 56, 112 plus 6, 12, 18, 48. When you add these two, you will get 160 into 160. If my multiplication is wrong, just correct me. Then multiply. The answer you get here is the final answer. It's not the final answer. You have to give the answer in tons. Here I am giving the answer in grams. Okay. So if I want to give the answer in, sorry, I am erasing all this one. You all might need it. Fe2O3. Fe is 56 into 2 plus 16 into 3. So if I want to convert this back to tons, I have to divide by 1000 to convert to kilograms, another 1000 to convert to tons. So this 1000 and this 1000 will get cut. This 1000 and this 1000 will get cut. Now we are left with a little bit easier calculation, no? 70 into 160 divided by 2 into 56. Further, you can cut this and this. 80. 70 into 80 over 56. What is 7 into 8?
56.
See, normally in our syllabus, they will give cuttable answer. So, I'm taking this to this side, Balana. 7 into 8, 56, and there are two zeros. That means 70 into 80, 56,000. Sorry, 5,600, not 56,000, 5,600 divided by 56. This and this will get cut. Our answer is 100 tons. Okay, now we were worrying, you sir, when you divide this by this, you will get a the decimal answer and all those things. But clearly, we can get a final answer. So don't worry. Somehow in our syllabus, finally when getting the answer, you will get a whole number answer. They will give questions in which you can do the multiplication and division without using a logbook or a calculator. Because for science, we don't take the logbook or the calculator. So for this, you will get 3 marks for finding the number of moles of step by step we have to do now. So if I am giving it in like step by steps for the students who are new, students who don't know these lessons, number of moles of Fe equals 70 million grams divided by 56 grams per mole. If you want, you can do and get the answer, find the answer here, but you don't, like, it's not compulsory. This is the number of moles of Fe. Then according to mole ratio, what is the ratio of number of moles of Fe and number of moles of Fe2O3? The ratio, mole ratio. 1:2, no? If this is 2, this has to be 1. If this is 4, this has to be 2. If this is 10, this has to be 5. Half of the value. So then you can write it again as number of moles of Fe2O3 needed is half of this. Half into 70,000 into 0 over 56. Then now convert to mass. Mass of Fe2O3. How do we do it? By using N equals simple M over capital M equation. Number of moles into molar mass will give you the mass of Fe2O3. So here shall I write it little bit in an easy pattern? 70 into 10 to the power 6 divided by 2 into 56. This thing I have, like, mathematically I have made it little bit shorter. Into molar mass of Fe2O3. Earlier also I showed you how to get it. We are getting 160. Okay. Then we are cutting this 2 and this one. It will become 8. 70 into 80 is 5,600. Divide by 56 into 10 to the power 6. Final answer will be in grams, no? So this and this will get cut, and answer will be 100 into 10 to the power 6 grams. How to convert to tons? That is your maths part. Divide by 1000, it will give kilogram answer. Divide by another 1000, it will give ton answer. Okay, so that means divide by 10 to the power 6. 10 to the power 3 is for kilograms. Divide by another 10 to the power 3 to convert to tons. So that means divide this by 10 to the power 6 to convert the answer to tons. This and this will get cut. Final answer will be 100 tons. Okay, this is like a step-by-step illustration for the students who are unable to catch up the method. And finally, calculations. Are you clear? More than the physics part, the maths part is more, no, here. One and only equation I used here is number of moles equals mass over molar mass. Grade 10, unit 7 equation, chemistry equation. Not even the grade 11 equation, only purely grade 10 equation. Yes, we'll see what are the questions available. Pavam sir, the 2016 batch. This is 2024, last year batch. Why did you convert to grams? Can do in kilograms? No. Yes, what Abdurrahman, what you are saying is correct. But here, our chemistry, can't we keep it in kilograms? Yes, I think you all will be getting the marks for that. But normally this molar mass is for grams only we do the calculation. That's why I convert it into grams and, like, completely did it in the exact chemistry method. If it is physics, Okay, if it is physics, then you can use kilograms. Are you all clear? Yeah, some want the previous page. I'll show the previous page. You all can take a screenshot. How many of you all tried this and got the answer? I'll be really happy. Yeah, tried it. Wrong answer, no problem. Tried it kiyana kattiya. I like those people only. Because more than getting the answer, you trying is the most important thing. Good. I'm happy about it. I tried but got the answer wrong. No problem, no problem. Now you know where you made the mistake, no? By coming to a paper class, you identifying your mistake is the most important thing. Not to show colors like I got highest marks, I didn't get marks. Not for that. I understood my mistake and I am going to correct it. That is the final output of this paper class. Yes, shall we move to the yes, there is one more question that is related to a simple general knowledge thing. Name a gas that is issue for the atmosphere when extracting iron by the above method and state an unfavorable effect of it on the environment. Actually, in grade 11, you will be studying it, but general knowledge wise, you all know carbon dioxide is the harmful gas. Carbon dioxide is the harmful gas. And global warming is the unfavorable situation. So for that, you will get 2 marks. Carbon dioxide is the gas. Situation is global warming. Carbon monoxide, actually that will cause problem in the lower environment. If we breathe only carbon monoxide is the problem. And also in this situation, Buddha, most of the carbon monoxides are used up. To convert the Fe2O3 to the Fe, the carbon monoxide is used up. So it's not that much released. But carbon dioxide is excessively produced. From calcium carbonate breakdown, carbon dioxide is produced. Coke reacting with oxygen also, carbon dioxide is produced. That Fe2O3 breaking down to Fe, there also carbon dioxide is produced. So in three situations, carbon dioxide is produced. Look at this. So excessive amount of carbon dioxide is released. Here, balanna carbon dioxide. I'll highlight it. In this reaction, carbon dioxide. Here also carbon dioxide. Here also carbon dioxide. But carbon dioxide is produced only once and again that is used up. So carbon monoxide is produced once and used up. So it's not a big environmental issue here, but carbon dioxide issue is the biggest problem. Carbon dioxide is a greenhouse gas. It will be causing global warming. So the final one, you will get 2 marks. Carbon dioxide, you can give the formula or you can write the name. Carbon dioxide. The environmental issue is not greenhouse effect. We call it global warming. Excessive greenhouse gases causing excessive greenhouse effect, we call it global warming. In grade 11, you will study due to global warming that is happening, this is happening. Okay, we have our grade 11 last tute. We are starting grade 11. This is for grade 11 students. I think grade 11 students are here. The last 2 lessons, hydrocarbon lesson and the biosphere lesson, our last tute. Hydrocarbon, we are starting for our grade 11 students this week. Online students. Physical classes, Vellavatta, I started. Kolonna and Dehibala, I have to start it next week. Online students, this Sunday we are starting hydrocarbon. And then hydrocarbon, I think in 1.5 weeks we can finish it. Then is the longest lesson, biosphere lesson. In that biosphere lesson only, you will come across this global warming, all those problematic situations. Hurry, then let's go to 2016. Come on. Yeah, last lesson for your O-level syllabus is known as biosphere. Okay, we call it the garbage lesson, dustbin. Why? Whatever they missed to add in grade 10, grade 11, finally they have added everything. Grade 10 students, you won't believe me that even the olden days Weber system, the history you study, the structure of a dam, Bisokotur, Alapanava, Sluice Gate, all that things are also here in science. Yeah, I think Abdurrahman gave a nice name, Kunukanda. Okay, that lesson is like our Kunukanda. There are few important points in that lesson, but other than that, majority is like whatever missed and Mekadamu. Okay, actually, I hate history. To study history, I like the real history of the earth, but to study history, okay, I hate to study the Sri Lankan history. I thought science again history, nah, but to see again here they have dumped it here also. Okay, let's go to our. Yeah, this is our current electricity thing. I'll just share this in the group. This is for the online students. Yeah, if you all like my session as a small contribution for me, you all can share this after the class. Now I'll put it in the group. While we are preparing for the 2016 question, you all can share it to your friends.
Sir, can you hear me?
Yeah, Buddha, tell me.
No, sir. Just want to check if you can hear me.
Yeah.
Chat is not working, sir.
Chat, okay. I didn't see your message, Varun. So our online classes are happening on Sunday morning, 10 a.m.
Keep everything.
Okay, shall we move on? So our grade 10 theory online classes are happening on Sunday. And also for the next year, we are shifting the classes to weekday because feel like night classes are better. So that will be, I'll be having more time to discuss a lot of things. So for now, for this year, for the next 2 months, November, December, we'll be having as usual on Sunday. Morning 8 a.m. we have grade 11. Then after that grade 11 finish, 10 a.m. our grade 10 classes will start. Next week, upcoming week, we are having current electricity lesson. So superb lesson. Many students, they complain that, especially if there is a lady teacher in school, I'll just tell you, don't get angry with me. Girls don't get angry. But commonly there is a saying that girls and electricity sette avadu. Okay. So some school teachers, especially the lady teachers teaching the electricity, electronics lesson, they have made a lot of common mistakes. Very common thing. Like for a male, live wire, we know because we do a lot of electricity things, we know simple things also. But some simple things have not been explained here. Got some complaints, but not all the lady teachers, some majority like. Okay. Okay, nice comments are coming. What has happened in school? Okay, then let's go to our 2016 one. Yeah, this is the question. Hope you all tried it. Superb question. Yes, Balan. Now let's go into serious focus. Write the write the balanced chemical equation. Question 6. Do we have another part in that? Yeah, this one. The gas is carbon dioxide, and the condition caused by it is global warming. Yeah, write the balanced chemical equation relevant to the production of iron from Fe2O3. You all know that, no? Okay, anyways, I'll quickly write it down. I'll write the answer here. No. Fe2O3 plus carbon monoxide will form pure Fe plus carbon dioxide. The balancing part, by now you all know, whenever you get this, put 3 here, 3 here, and balance Fe. Someone's mic is unmuted. Okay, good. So we know the ratio. Now, Balanna, superb question. In the process, 1680 kilograms of pure molten iron was obtained. Sorry, this side. Molten iron is this one. No, pure iron was obtained. Here the 1680 kilograms. Obtained from 2520 kilograms of mixture of Fe2O3 plus impurity. So it is not the mass of pure Fe2O3. You can't divide it by the molar mass of Fe2O3 and get the number of moles of Fe2O3, because this 2520 kilograms is little bit of impurity and large amount of Fe2O3. We don't know how much. In this case, assume that all the Fe2O3 reacted completely. Okay, this all the Fe2O3 reacted and only we got this much amount of Fe. Find the number of moles of molten iron obtained and calculate the mass of Fe2O3 reacted. What is the mass of impurities present in the mixture? Superb question. I'll transfer this to this page. Fe2O3 plus carbon monoxide will form Fe plus CO2. Here we put 3, here we put 3, and here we put 2. So the mole ratio between this and this is, if there are of Fe produced, there should be 1 mole of Fe2O3. Yeah, in the values, 1680 kilograms, 1680 kg. The other one is 2520 kilogram. That is the whole, let's say, Fe2O3 plus, okay, some impurities. You all know what are the impurities, no? Silica and alumina. Still they have not reacted, no? So we can call them silica and alumina. All the others are pure Fe2O3, but we don't know the value. So now first thing is we have to find the number of moles of Fe produced. So number of moles of Fe produced. Here you can use the grade 10 equation. N equals simple M over capital M. Simple M over capital M. Simple M is 1680 into 10 to the power 3 grams. I'm converting this to grams because in chemistry we have to do it in grams. That is the reason. You can keep it and do it in kilograms, but additionally 3 zeros you will have to add. That's the only difference. Divide by the molar mass of Fe, they have given, that is 56 grams per mole. Even if you don't put the unit, no problem. If your final answer is having the proper unit, correct. Because here in this situation, final answer will have moles as the unit. So always I told you in our syllabus, they will give cuttable values. The values which you can cut.
30,000.
Balan, 56 into 3. 6, 12, 18. 1 here. 5, 10, 15 and 16. 168. Easily you can cut this and this. Don't think the values are like, too big and that and this. Always they will be giving cuttable values. So answer is 30,000 moles I'm just writing it 30 into 10 to the power 3. Clear, right? How 10 to the power 3 came? Puta, kilogram. Without writing, when converting to gram, I multiplied by 1000. Now, if this much moles of Fe is produced, how much moles of Fe2O3 should have been there?
Can you show me when you finish?
No, ma, I can't see that. Sorry, sir.
Oh. Number of moles of Fe2O3 reacted. Puta, this all comes with the mole ratio. Just tell me one word to finish it off. If this is 30, this Fe2O3 will be half of that. Because half, no, it always has to be
15,000, sir.
half. Mole ratio is 1:2. So what is half of this 30,000?
50,000. 15.
15,000 moles. Now, Puta, how to find the mass of Fe2O3? I ate, Baba. Thank you. My small fellow has bought dinner for me. Give me a minute. Come. Yeah, this is our Rahid. Say hi. Say hi. Bye then. Go then. Okay. So, mass of Fe2O3 is, again you use the grade 10 equation, N equals simple M over capital M. If I want to find the simple M, I know the N, I know the capital M, molar mass, I can find it. Earlier, previous question we found 160. If I can find that, then when I can multiply N into capital M equals M. So to find the mass of Fe2O3, I have to take 15 into 10 to the power 3 moles and multiply by the molar mass. Here I'll put the direct value 160. Because in the previous question we did it, right? The ones who came late or ones who are not there, I'm just telling you, Fe2O3 is 56 into 3, into 2 plus 16 into 3. You're getting 48 from one side, from the other side 112.
160 is the answer.
160 grams per mole. Harine? Now when you multiply this is the mass of PoFe2O3. So here you will have to multiply 16 into 15.
So it's 2.4 million.
Yeah. 2, 4, 0. Here there is 1 0 and here 3 zeros. So that 3 zeros, can I directly now write without those 3, 10 to the power 3, I can write kilograms, no?
Yes, sir.
I can write that. That's a maths part, you all know. It will be or else, okay. There might be some students who don't know that. We get the answer as this much grams. When we convert to kilograms, 2,400 kilograms. That is PoFe. Now we got the answer for that question. Now the next question, they are telling us find the impurity amount. Total mass of the whole stone was 2,520 grams. Now we got PoFe2O3 2,400. So total is 2,520 kilogram. PoFe2O3 inside that is 2,400 kilogram. Then when you subtract these two, what will you
It's
get?
120 kilograms.
Impurity. We are getting 120 kilogram impurity. See, such a superb question. I actually like this kind of question. This will make this gray matter, the brain, to work more and more rather than giving Baba, Totta Baba questions and making you all, okay. Now see, you can't say any reason. The first new syllabus paper 2016, we got this hard question. The previous paper, 2025 students, you can't complain. 2024, also they gave this kind of a hard question. Just now, previously we finished that. That tons, that question. So now you can't say, no, so starting they will be hard, after they will be making the paper easy. You can't say starting is easy, now it is hard. Always they maintain a standard level for the paper. So only thing is you have to prepare for the worst and go. Be prepared. Whatever question they give, you should be able to answer. Will we get these type of papers, questions in the paper? God only knows. Until the paper comes to your hand, we don't know. Because the blast furnace question last year, okay, last year's paper, we never expected them to give a hematite. Okay, hematite question එක දුන්නත්, I thought it will be more easier, flexible, because that is the corona batch that lasts. Now I think 2025 will be the last batch whose exam is getting postponed. 2026, okay, you're the unluckiest batch. Why? All the other batches got extra time, 1 month or 2 months or 3 months. Your exams will be in directly December. So you all are kind of unlucky. So yeah, that first year of new syllabus itself, they gave this question. How would it have been for those fellows? 2016 fellows. Actually, they are power because they had to study the new syllabus. Teachers had to get adapted to new syllabus. Normally, when a new syllabus starts, that year's O-level paper will be little bit easy. But 2016, like one student gave a nice comment, first ball itself, yoga. Them are like hard question. Okay. So that's how our people are. So we can't predict the paper, but we have to prepare for the worst. Okay, so that's why please attend the paper classes, because in theory classes I can't be doing all these questions. No, so see, for just one question, I think we took about 1 hour to complete both the 45 minutes just for one question. Like, because I had to fully explain and all those complete it properly. Okay, so it's like that. So that's why I'm telling you, please attend the paper classes. Once you come to grade 11, we will start the past papers early itself, because 2026 batch is having 9 years of past papers. 2016, 2017, 2018, 2019, 2020, 21, 22, 23, 24. And the 25 batch also will be there, no? So we have 10 years of past papers. I'll tell you one thing, okay? The more number of past papers you have, the harder your paper is going to get. Because you all have seen all the possible questions, no? No, normally for a syllabus, maximum 4 to 5 years, that syllabus will be there. Because of corona, economic crisis, political crisis only, this year 2016 syllabus has been extended to 10 years. Some of the theory which is available in the textbook now is not available in the world. For example, they talk about milk of magnesia to treat the gastritis. We have better medicines. Now no one sells. There are some special pharmacies, they sell the milk of magnesia, but it's not very common. Okay. In one place they have said LED bulbs are very expensive, therefore people are not using it. Now it's very cheap. 10 years pass. In PETA you can get for 200 rupee also you can get LED bulbs. Okay, so therefore, the more amount of past papers you have, the more harder your paper is going to be. So what I am saying is prepare for the worst. Think that it's going to be totally hard and prepare. Then if the paper is easy, you're going to, be like, when doing the paper, you're going to float. And the parakara, they say that kind of level. Okay, so please keep on doing the work. 2025 batch students, if you all are there, okay, now your hard work should continue. Okay, without any fail, without any laziness, you have to continue your work. You all have only 3 months more. But the 2026 batch, you all also start working hard, do all the old revision. This is your 3rd term. I will have my final paper in December. I want all of you all to participate and do the final paper properly and get your marks. Okay, then before that, do all the revision. When coming to grade 11, come with your full grade 10 knowledge. Nathang grade 11 is going to be tough. Then at that time, you have to attend grade 10 as well as grade 11 classes. Okay, then I hope you all understood
Sir,
this session. Any doubts with this?
sir,
Yes, Buddha.
sir, all the 10 years paper from 2016 to 2025, will it be there in eTaxela, sir? The website?
2025 is not there. If it is there, I am
Sorry,
also happy. Okay, until 2024, it is there.
okay, sir.
Okay. So yeah, thank you for joining the session. I hope you enjoyed it, and I hope you understood, got a lot of knowledge. Okay, so keep up this. So again, most probably next month we will have 2 paper classes. December 1 paper class, because December our theory class is also going to be a paper class. We are going to do our final third term exam. So O-level structure. O-level is like this, no, Buddha? MCQ 40. Each question 2 marks, therefore 80 marks. Structured essay question, 4 questions. Question number 1, 2, 3, 4. 1 will be bio, 2 will be bio, 3 will be chemistry, 4 will be physics. This is structured essay. You have to do it in the paper. Each question 15 marks. So 15 into 4, totally 60 marks. Here I am putting the total. Essay questions, we have question number 5, 6, 7, 8 and 9. 5 will be purely bio, 6 is chemistry, 7 is physics. 8th question will be biophysics combination. Okay. 9 will be chemistry physics, both the tough ones. Each question 20 marks. Out of this you have to select only 3 out of 5. So 3 into 20, 60 marks. Totally you will get the marks for 200, and they will divide that by 2 and get your 100, whether you're getting A, B or C or whatever is counted from that. This is the basic structure of the O-level paper.
Just small question, sir.
Sorry?
Small question. Sir, 3
Yeah.
out of 5, you can choose from the essay type questions, right?
Essay type. Structured for all 4 compulsory. This is compulsory. This one, 3 question out of 5. Now, if you hate bio, you can select chemistry, physics combination. But don't, I'm like, try all the 3 probably, because there are some students, they say, I hate bio, sir, I won't study that. No, study it. Okay, we don't know which question is going to be easy.
Sir, do you know the general timing for each science paper?
Okay, so 1 minute. Some student has said, if you get the paper compulsory, we want to tell anyone. I can't understand. If it released to you, so new publish was not hard. I can't understand that. I thought if the paper is released, please tell us compulsory. Actually, even if I get the paper, I won't tell it to you. Why? I won't get it. Any tuition teacher won't get it. Okay, but the thing is, even if I get, I won't tell you, because our 2 years effort will just go in the drain if I give you all the questions, no? O-level questions. Okay, so the effort which we do, we want to do the exam and get a good results. That's the, like, final output. I don't know whether that girl was trying to tell that or something else. Can send me a WhatsApp message. Yes, Umar, you were telling something.
Yeah, sir, what's the general timing for the science papers, sir? 3 hours, right?
Yeah. MCQ 1 hour. Here only our timing is important, MCQ, because 40, each question 1.5 minutes, 1.5 minutes. Okay, but I want you all to finish it within 1 minute, so that you have finally 20 minutes to double check your paper and do the hard ones. For some chemistry, physics calculation, you will take more time. So 1 hour, 60 minutes for 40 question. Structured essay and essay, you have little bit more time. Both together, we have 3 hours and 10 minutes. They are giving now 10 minutes extra to select which one you are going to answer out of 5. Can you send your all tunes
Okay,
on
sir.
group? It's already there. There is a link. When you go to that link, all the PDF will be there. PDF can my presentations, whatever. That's for the theory. Papers are also available. Okay, then students, again, will meet in November next month. Third, I think first week we can have, no? November first week. That is third. And inshallah, November third week. That will be on the 17th. These 2 days, again, we will have the free grade 10 paper. If I have any issues, I will change the date. Again, on Monday, out of the 4 weeks, you will have to. Can do all 5 and write low marks, cut one. Okay. We'll discuss about that once you come to grade 11. Can you answer more than 3 questions in the essay type? Okay. Will the grade 11 also have a paper and lightweight? Yeah, grade 11s, we are having the paper class. Now, soon after I finish this, we are having the grade 11 paper, but grade 11 paper is a paid one. You have to purchase it from the website. Yeah, I have only 7 minutes. Once I finish this, I have to prepare for the grade 11 paper. Okay, then we'll end the session. I hope you
Okay,
enjoyed
sir.
it.
Assalamu alaikum, sir.
Wa alaikum salam. Good night to all of you all. Okay, see you all of you all.
Jazakallah.